Welcome to solverfy.
So we know that the magnetic force is given by q times the cross product of velocity and the magnetic field. This information says that the force vector is perpendicular to the velocity and the magnetic field. Okay, so yeah, and this means that magnetic field is perpendicular to the force vector, and magnetic field cannot be parallel to the velocity vector, otherwise the force will be zero. But we have some value of we have non-zero force over here, so the magnetic field cannot be parallel with the velocity vector. So using these information, so for this case f1, so let's consider f2 because magnetic field is constant in the total system. So let's use f2. So f2 is in positive x direction. So let's write it this way. And velocity v2 is in the z direction. And so B should be parallel, the magnetic field vector should be perpendicular to F2 but not parallel to V2. That means the only possibility of direction the magnetic field can have is along y direction, because this is the only case in which B can be perpendicular to F2 and at the same time not being parallel to the velocity vector v2. Now let's calculate the force F2 using these equations. So F2 is Q times v2 vector times v vector. So this gives Q times the magnitude of v. So let's find just the magnitude. So this gives v2 to be charge, the velocity, the magnetic field vector, and we have the direction k cap cross j cap. So the k cap comes from velocity and j cap comes from the magnetic field vector. So let's put now a vector sign, and this is equal to I cap, same as we found here, but there is a negative sign to it. So this is going to be negative now. This means that F2, the magnitude is going to be negative of QV2 by, because we took F2, or F2 is given to be in the positive x direction. So the magnitude, so we are going to include the negative sign with the magnitude of F2. This means that the velocity, okay, so this is basically B, which is in the y direction. So this gives the magnetic field to be equal to negative of F2 over the charge times the velocity. And this is equal to negative F2 over the charge times V1, because V2 is equal to V1. And so we can write the vector V to be negative F2 over QV1 and the direction, which is j cap. Now for the second part, oops. So this was our first part. For the second part where we have to find the force, we will use the same equation as this. So Q times V1 vector cross product of B vector. And this is equal to Q times V1 times the magnitude of the magnetic field times sine phi. And sine phi is given to be 45 degree in this case, because we already found B to be along the y direction. So this angle is also 45 degree. That means phi is 45 degree. So this is equal to Q times V1 times B 1 over root 2. And we use the value of B that we found here and substitute over here. And this gives, so let's do that. So this is negative F2 over Q times V1 1 over root 2. So this gives the value to be F2 over root 2. Now, one particular thing to consider over here is, while we are taking the magnitude, we should take, magnitude should always be taken to be positive. And so this becomes plus here. That means F1 is equal to F2 over root 2. And this points in the direction as shown here.